Reverse engineering allows researchers to isolate the part of the program that is not working or could use improvement. To this process, researchers can also learn about how to improve their program when they put it back together again. The process of reverse engineering was originally applied to hardware only, but it is now being applied to software, databases, and even human DNA. In the process of cybersecurity, reverse engineering can be used to identify how the attacker entered the system and what steps were taken to breach the system. Reverse engineering enables to identify the hacker's technique to prevent in the future. The researchers who reverse engineer software are usually looking for bugs or flaws in the software that could impact their operation, their security, and ability to exchange information or how they process data. Reverse engineering can also reveal accidental errors or intentional harmful code, such as a virus hidden in the software. And it can also reveal ways to repurpose the software for new uses. You have probably run into interoperability problem at some point with your document. For example, while opening a Word on a Mac computer may present a compatibility problem. Reverse engineering can be used to study a program's code to improve its interoperability, allowing the software to run on different OS systems or databases. So, continuing with our example as above, someone might want to reverse engineer a Microsoft Word in order to change its code so that it could run on a Mac. Similarly, in case of maintenance work, reverse engineering can be a very good tool for maintenance work. Useful software are constantly evolving, and to provide new features or remove unused ones, you can reverse engineer a software. Software maintenance is very important as it ensures new code and old code can both successfully work together. It can make it work together. So maintenance work is made much more difficult when there is no documentation to explain the code to the programmer, either because the documentation was never written. I know you feel it, right? Or because it was never updated. So in that case, reverse engineering becomes an important tool for a programmer while conducting maintenance work. Besides that, for circumvention purposes, a software that you buy comes with compiled object codes that only the computer can understand. The creators of the software do not want you as a user to have source code, since it could be illegal to modify it. But in with reverse engineering, is sometimes used for the purpose of unlawfully duplicating copyrighted work or gaining access to the program without paying. So to prevent circumvention, some programs require, as a part of the terms of use, that you do not attempt to re-engineer. So for circumvention purpose, you can use reverse engineering. Reverse engineering is divided into four steps, and the steps of reverse engineering goes like this. The first is the pre-screening, second is decompilation, third is the verification, and finally the creation. The pre-screening process. In the first stage of reverse engineering is the pre-screening process. You will determine the candidate products for your project. That means that you are getting to choose the product. That is the step when you choose product. The product can be selected on the basis of the market needs, or how popular or how expensive product is, or according to the market needs. When you pre-screen, you can examine the product strength, identify its weaknesses, its performance, security, interoperability. So it's basically like performing the SWOT analysis of the. So the second step is the decompilation process. As you know, when a software is developed, the code that the programmer writes is called the source code, and it has to be translated into code that a computer understands, and it's called object code. So the source code may look like, for hello world, let's say hello world, print hello world could get translated into object code that looks like 00100, series of zeros and ones. This process is known as compilation. During this process, the programmer's notes and comments explaining about how the code works. Decompilation reverses the compiling process. In, in decompilation, reverse engineer attempts to translate the program object back to the source code which the programmer can understand and analyze. Third is the verification stage. In this stage, you'll verify that all the pieces that you discovered during the second stage add up to create an accurate replica of the original, the product itself. You'll verify the accuracy and validity of your design by testing the system, creating prototypes, and experimenting with the results. Verification methods may differ with each project, and it's different for every project. However, the testing and analysis you perform should ensure the components meet the specific design requirements of the project. The final stage is the creating stage. Now that you have a working replica that has successfully been made, you can adapt and tweak it a little to create a new product that has more advanced abilities. The product you create could have competitive design, innovative features, or enhanced capabilities. Your product may also be an adaptation of the original product for use without with their other integrated systems such as a different platform of computer system.